Okay, so let's start with today's session. So what we have covered in the last week, so we have discussed about the recursion in the last week. So today we are going to do dynamic programming. So let's first discuss why dynamic programming. Why we have studied recursion first, then we are coming to the dynamic programming. So as we have seen in the recursion that we were dividing the problem, a complete problem into the sub problem. Okay, let's say we have to calculate a Fibonacci number, let's say of 8 terms. So I should be knowing the seventh term as well as the sixth term. So I was just adding both terms and I was getting the Fibonacci number of the eighth term. So what we are going to do today, so as we have already discussed some part of the dynamic programming in the session also. So let's start it from the very basic, why dynamic programming. So as we have seen that in the recursion that we were dividing our problem into the sub problem, and what we have seen. Okay, just 1 minute. Let me share my screen. Okay, so let's say there is a problem. Okay, let's say there is a main problem, something like this. Okay, just one. Okay, let's say there's a problem, and what I have to do, what I'm doing, I'm just dividing it into sub problems. Let's say two sub problem. Okay, so let's say this is the Fibonacci of the eighth term. I'm looking for the Fibonacci of the eighth term. So I should be knowing seventh as well as the sixth. So I can calculate that. So for knowing the seventh term, what I was doing, I was calculating it for the sixth term as well as the fifth term. Okay. So it will go something like this: sixth term as well as the fifth term. So for six, it will go for fifth as well as four. Okay. So it will continue in that manner. And what let's say it has completed, it has calculated the Fibonacci of the seventh term, and now it is looking for the Fibonacci of the sixth term. But what to do now? It will calculate for fifth term as well as the fourth term. Okay. Again, because we have not stored our value, that we have already calculated the Fibonacci of the sixth term, but we have not stored it somewhere. So what our function is going to do now, it is going to calculate it again. Okay. So as we can see that we are wasting our time as well as the resources. Okay. So in order to reduce the time complexity and reduce the uses of our resource, what we can do, we can just create a DP array. Let's say in this case, I'll be creating a DP array. So what I can do, I can just not in the array. We can do the DP dynamic programming in using any of the data structures, that is linked list, tree, binary search tree, any of these. It will depend on this question. So right now, what I need, I just need an array. So what I'm doing, let's say if it is 7, if I'm already calculated if I've already calculated the value of 6, so what I'm doing, if I have calculated the value of 6, I'm just storing the value of 6, and after that, if somewhere else in the program, if I need the value of 6 again, I'll be using that value. I'll not calculate the value again. Okay, is it clear? So in the simple terms, what we can say, the dynamic programming is, let's say, is dynamic programming is a breaking down an optimized problem into a simple sub problems and storing the solution of each sub problem and storing the problem of each sub problem, so that the sub problem should be calculated only once. It should not be calculated more than one time. Okay. So it means if I'm dividing a complete problem into the sub problems, I should be calculating the value of that sub problems only once in my program, not many a time. Okay. I can use many a time, but I should be calculating it only once, and I should be storing it somewhere so that if I need it in the future and somewhere else, so I can use that value. Okay. Is it fine? I think we have already discussed the example of Fibonacci series in the last term, in the last session. So I hope the dynamic programming is clear. Why dynamic programming and why with the help of recursion? Okay, if you have any queries, you can write on the group chat. I don't know why my chat is not visible to me. Just 1 minute. Let me share my screen again. Oh, I can see the chat board. Okay, if you have any queries regarding the regarding this, the dynamic programming, you can ask me right now. With the basic of it means the theory of the dynamic programming. Why dynamic programming and why with the help of recursion? Why with the help of recursion? Because we all know that recursion helps us to solve our sub problems. If I know the problem, if I know the solution of my problem, it's, let's say, it depends on the sub problems as well as the my solution. So the sub problems that recursion will solve for me, and my part I'll do by myself. Okay, so in this way we can take the help of recursion in the dynamic programming as well. Okay, so what I'm going to discuss today, I'm going to discuss a very famous problem of the dynamic programming, that is longest common subsequence. It is the most famous problem, I think so, of dynamic programming, and it is a good number of time the companies has already asked this question. So what we'll be doing, we'll be discussing about this problem, and side by side we'll be seeing how we can approach a problem of dynamic programming. Let's say this if is some problem somewhere, and if we know that yes, it can be solved using dynamic programming, or you don't know, let's say how the process starts, and how we are going to see, how we are going to learn that how I can use, how I can apply the dynamic programming of that question. Okay, so let's first understand about the question, then we'll be talking about the solution. So what longest common subsequence is? Let's say you have given with two strings, let's say a, b, let's say c, d. This is a string a, b, c, d. Okay, and you have another string that is, let's say, d, b, c, and a. Okay, so if I talk about the longest common subsequence, okay, let's first discuss what is the subsequence of an let's say string or array. So subsequence, could you say how recursion is better than loops? I've never said that recursion is better than loop. It depends on it depends on the question, what the question demands. And we cannot say that iteration is better than recursion or recursion is better than iteration. It depends on the need. Sometimes, let's say in the case of, if I talk about the, if you're saying that how recursion is better than loops, if I talk about the Tower of Hanoi problem, if you solve it using the with the help of iteration, it will minimum, it will take around 50. I mean, recursion, is there any parallel computing? No, in iteration there are also parallel computing. And so if you're talking about the recursion, how recursion is better than loops, what I was talking about the Tower of Hanoi problem. If you solve the Tower of Hanoi problem with the help of iteration or loop, it will minimum cost you around 60 to 70 line. What I can in minimum 60 to 70 line I can do that, minimum, not less than 60 or 70 line. But what in Tower of Hanoi is problem, if you ask me to do it with the help of recursion, I can do it with the help in, I think, 7 or 8 lines. So if you understand the question in the form of recursion, it is easy to code. Okay, so if you are able to do it with the help of recursion, so you'll be if you visualize the answer, let's say if you visualize the code how it is going to calculate all these values, so after that you can do it with the help of iteration as well. So I would say that why recursion, I'm not saying that recursion is better. In my words, if I say, let's say, if you're talking about the recursion, I'm saying it depends upon the situation. Let's say in some form recursion will not be that much sufficient, iteration will be easier. Let's say in the case of TP, sometimes in the, let's say in this problem only, longest common subsequence, sometimes you'll see that if you write the recursive solution with the help of memorization, it will say that on the some platforms, online platforms, it will say that time limit exceeded. But if you do it with the help of iteration, so in that form you'll not get that time limit exceed, because in the form of recursion, what we need to do, we just although we create a DP. Okay, we'll talk about that in the coming part, I think so that everyone can get that. We'll be seeing that with okay. So okay, let's come back to our question again. Longest common subsequence. Yes, it depends upon the problem. So what longest common subsequence is? So I was talking about the subsequence first. Let's see what a subsequence. Subsequence is it's let's say if I need if I want to print the subsequence of this string, let's say. So what can be subsequence? Subsequence can be anything. Let's say you can write any of the subs. It's just like substring, but it does not matter that it should be continuous. It does not say that it should be continuous. Let's say what a substring says, A, B, C will be the, let's say A, B, C will be the substring of this main string. But if I say A, C, D, will it be the substring of this main string? No, it will not be the substring because it is not continuous. Because substring says that it should be a continuous part of that string. But what subsequence is? Subsequence is it does not matter. It does not depend or does not matter that it should be continuous. It should be just in a sequence. Like if ACD, yes, ACD, it comes in a sequence. So ACD will be the subsequence of this main string. Okay, so every substring is a subsequence, but every subsequence does not guarantee that it is a substring, because this is a subsequence and it is not the substring of this, but it is a substring of the main string, and it is also a subsequence as well, because A, B, C in the same it is in the same sequence, and it is a subsequence of the main string. Okay, let's say A and D. Yes, A and D is a subsequence, of course, because after A, D is coming. Yes, in this main string also, after A, D is coming. Okay. If I write, let's say B, C, A, will it be a subsequence? No, because yes, first B is matching. Okay, B is matching. C is also matching, but after C in this main string, nowhere the A is coming. So what we can say that it is not the subsequence of the main sequence, main string. Okay, I hope you got the subsequence. So if I try to print the subsequence of this string, so A will also be the subsequence. B will also be the subsequence. C, ACD not subsequence. ACD will be the subsequence, of course. Why it will not be the subsequence? Because after A, C is coming, after C, D is coming. Okay, so A, B, C, D. So length of one and four will be the, let's say there will be four subsequence of length one, and after that AB, BC, CD as well as AC. So what we can say that here the number of subsequence will be very large. Okay, let's say because if we try to create the let's say if we try to create the subsequence of length 1, so it will be NC1. We all know that it will be NC1 because it will be n, as we have already seen that if the length of this main string is n, so it for length 1 it is NC1 because it is coming out to be 4. Okay, so NC2, NC3, NC, it will go up to NC1, NCN, sorry, NC2, so it will go up to NCN. So it will nearly come about 2 raised to the power n. So for length of n subsequence, the number of subsequence would be 2 raised to the power n. Okay. So let's come back to our question again. What the question says, let's say what the question says that tell me the length of the longest common subsequence in both the string. Okay. So if we see that which will be the longest common subsequence, or yes, it depends, it can be more than one, but it is asking us the only length of that subsequence. Okay, so in this case A, B, C, D, and we can see that B and C is the common subsequence, is the maximum is the of maximum length of the longest length. Okay, B and C. Okay, so it is coming out to be 2. So answer should be 2. But what I'm asking about, here we can see them manually, but how I'm going to code it, how I'm going to see that whether which one is the means what is the length of our longest common subsequence. So for doing that, let's slightly move to the algorithm part. Let's see first how we are going to solve this problem. Let's say we have given with two strings. It does not matter. Let's say here A is also there. Length of it does not depend that length of both the strings should be same. Okay, so let's say here A, B, C, D and E is given, and D, B, C, A is given. So we know that B and C will be the longest common subsequence, yes, but how we are going to code it in the form of our program. So we'll be doing it, let's say, let's slightly think about it. Let's give it 1 or 2 minutes. Let's see how we are going to do it. So for solving a longest common subsequence, let's see what if I say what if I say that if I know, let's try to think in the form of recursion. Okay, let's see if I'm saying if both of these two character matches, it means if both of these two character matches. So I'm going to say that what is the longest common subsequence between these two strings, return me and add 1. Okay, just think little bit in the form of recursion. What I'm saying, it is not matching here, but what I'm saying, just try to understand. If I'm saying that if A is equal to D, it means the string of this, let's say it is S1, the S1 of 0 and the S2 of 0, if it match, then what you need to do, because I am looking for the longest common subsequence. If two character match, so what I'm going to do, I'm going to check, I'm going to see whether both of these two matches or not. Let's say what I'm going to do, I'm going to look for that the longest common subsequence in this and in this. Again, if I'm saying if it matches in this, if B and B matches, so I'm going to say CD, look for the CD, E and CA. Okay, so okay, let's remove this. Let's come back to our part again. So what I'm saying, we can do either we can do it with the starting or we can do it from the end. So let's say now if I'm saying, let's try to think in the other way also. What if I say that if E and A matches, if E and A matches, so I'm saying that calling my function for ABCD and DBC now. I'm saying that tell me the longest common subsequence between these two and add 1 and return the value of that to my main program. Okay, so if I'm saying C and C match D matches, again I'm saying pass the ABC, although it is not matching here, but I'm just talking about the how we are going to do this. Okay, so let's so we are thinking in both way. Okay, so what we are going to do now, let's say if E and A does not match. Okay, if E and A does not match, in that in that situation, what we are going to do, if E and A does not match, we don't know, because we are looking for the longest common subsequence. So in that case, it can be in this or in this form. It means it can be the longest common subsequence can be from these two strings, or it can be from, let's say, it can be from these two strings. Because I hope you're getting what I'm trying to say. Let's say it means here it can be from this complete string and left the one and leave the one in this. And I'm saying in this form, leave the one last one in this and take this complete string. So what I'm trying to say that if E and A does not match, so the longest common subsequence could be from ABCD and DBCA, as well as it can be from ABCDE as well as from DBC only. Okay. So what I'm trying to say that what I would then in that case, what will be the answer of that question? What will be the answer of that situation? We are looking for the longest common subsequence. So I'll say that call my main function for these two strings as well as these two strings and take the maximum from that function and return to my main program. Okay. Let's take a small example. Let's try to try run our what solution we are thinking. Then we'll be seeing whether we can say that we are thinking in the right way or not. Okay. Right now, I'm not discussing about the DP solution. I'm just discussing about the how we can think it in the form of recursion. If we can think a problem in the form of recursion, we can easily apply the DP, or we can. It will not take that much time. It will not take that much time to understand the DP solution. So if you're starting with the dynamic programming, I'll recommend you to first think a problem in the form of recursion only. Okay. So let's say if I'm writing X, Y, Z, let's say this is string 1, S1, this is string 2, S2, S2 is Y, Z, and X. Y, Z, and X. So now what I'm saying, let's say if I'm trying to create a tree, a recursive tree, how I'm going to call my function. So if xyz and yzx is being passed through our function, what I'm saying, if z and x matches, then what you need to do, add 1 and call the function for x, y, and yz. But in this case, we are saying that z and x does not match. So what we are going to do, we are going to call this function 2 times and going to take the maximum from this. So I'll be writing m here. It means that I'll be taking maximum from which one is the maximum, which one will return the maximum. I'll take that value and I'll return to my main program. Let's say main function is this, that is main. Okay. Okay, let's think that this is the main function. Okay. So what I'll be passing through these two branch, because I'm looking for the maximum length. So in that case, I'll pass xyz, as we've talked that we'll be passing xyz. If I'm passing this complete string, I'll remove x from here. I'll pass y and z. Okay. And here, if I'm passing xyz completely here, then in this case, I'll remove z here. I'll pass xy. Okay. And because this will be I have to pass two string. And in this case, I'll pass the complete string y, z, and x. Okay. So again, if I'm passed, I'll call my main function for these two strings and these two strings. So which one is going to return us the maximum value? I'm going to take that. I'm going to return that value to my main function, because right now if I can see that z and z matches. If z and z matches, what I'm going to say, I'm going to call my function for x and y. Okay, x and y and y, because I'll be removing my z. I'll not calling my function for 2 times. I'll call my function for 1 time, x, y, and y. And whatever the function is going to return, I'm going to add 1 to it. Okay, because I know that z and z matches. Let's try to solve the first left subtree, then we'll try to solve the maximum right subtree. So it is y here. Okay, it is not the x, so it is y. So again, y and y matches. So in that case, what I'm going to do, I'm going to call this function for x this side, for x this side. See it very carefully. Why I'm calling for x, because y and y matches. I'm calling it for x as well as a null, because here it will not be anything, so it will null. So I'm not writing anything. So whatever this function is going to return, I'm going to add 1 to it. Okay, let's say I'm going to add 1 to this, because y and y matches. So I'm calling this function for x and null. If it is going to return something, I'm going to add 1 and I'm going to call this return to my calling function again. So what if there is two string given, if there is x and there is null, there is nothing. In that case, we know that the longest common subsequence will be of length 0, of course. If there is nothing common, so it will be, let's say it will be of length 0. So in that case, I'm going to return from here. Let's say this function is returning 0. So if it is returning 0, I'm adding 1 to it and I'm returning my function to this function, because it is also adding 1 and it is returning 2 to it. Okay, so it is going to return 2 here. Okay, let's try to solve the right part, then we'll be coding it. Okay, so again, if I'm going to check whether y and x matches, no, in this case y and x does not matches. So I'm going to call this function 2 times, because if it does not match, so I'll be calling it for, let's say it is for xy. If it is for xy, if I have taken this complete string, then I'll be leaving x in this part, so it will be y and z. Okay, here if I've taken the complete xy here, so I'll be removing x from there, and I'll be taking y, z, and x. Okay, so if x and y, again I'm seeing y and z does not match, so again I'm going to call this, whatever this function is going to return, this two function is going to return, I'm going to take the maximum one. So again it does not matches, I'm going to call this function for 2 times again. It is for x, y, it is for x, y, and y. Okay, just try to see it very carefully. Why I'm trying to create this tree, we'll get it very soon. So if x, y, and y, okay, because I'm taking this complete string and taking removing the z from here. Now what I'm going to do, I'm going to remove y from here. I'm going to call x as well as the this, let's say this is x and y, z. Whatever these two function is going to return, I'm going to take the maximum one and I'm going to return it here. Then I'm going to solve this for yz. Okay, no, this is for the complete function. Then I'm going to return it again. I'm going to call it, try to solve it the right part of this subtree. Whatever it is going to return, I'll be taking the maximum from both and I'll be returning, let's say it is returning x here, so I'm going to take from maximum from 2 and x. So in this case it will return 1, because as we can see in the x, y, and y, z, x, we can see that the maximum longest common subsequence would be y or x, so it will be of length 1. So why I have created this recursive tree, as we can see that for x and y we have already calculated that its length will be, for x, y, and y its longest common subsequence will be 1. Okay, for x, y, and okay, so again we are going to calculate it again. Okay, so we are seeing that yes, we are again calculating the same calculated thing that we have already solved. So as we have talked about, as we have as I've said that in the TP, I'm going to solve a sub problem only once. I'm not going to solve the sub problems again and again if I need it somewhere. So what if I would have stored it somewhere? So in this case, I would have not to calculate it again and again. So I could have saved a lot of time here. Okay. And in this part also we'll get some cases in which we have all that cases we have already solved, but we have not stored it somewhere, so we have to calculate it again and again. Okay, so we are seeing that. So first let's code it in the form of recursion only, then okay, I'm going to remove it. Is there anyone who is having any problem in this recursion tree? How I'm solving the longest common subsequence in the form of recursion only? TP will talk about that. Even write on the group chat if it is fine. If you're comfortable in it, I can write the. Okay, Vidura is saying I can repeat it quickly. Okay, I'll repeat it quickly. So let's say x, y, and z is given, and y, z, and x. There are two strings are given, and I'm looking for the longest common subsequence. So what I'll be doing in that case, let's say if I'm checking the last character of both string, if it matches, what I'm going to do, if it is matches, I'm going to call the function for x, y, and y, z, and I'm going to take what is the value that is going to return, and I'm going to add one because I know that last character matches. But in this case, we are seeing that z and x does not match, so I'm going to call this function for x, y, z, and yz. In the left part, x, y, z, and yz, and in the right part, why I'm calling this for x, y, z, and yz? Because if z and x does not matches, I don't know. The longest common subsequence could be from x, y, z, and yz. So because it cannot be from the maximum both of the strings, so I'll be passing my x, y, z, and y, z here. And in the second form, I'll be passing my x, y, and y, z, x, because I don't know from which both string I'll be getting the longest common subsequence. So again, here we are seeing that z and z matches. So I'm calling my function only one time, because if z and z matches, so I know that x, y, if I know the value from x, y, and y, that what is the length of that longest common subsequence from x, y, and y, I can add 1 to it and I can return it to my main function. So here what I'm calling it for x, y, and y, and whatever the value it is going to return, I'm going to add 1 and I'm going to return it to my calling function. Okay, so again here we are seeing and y again matches. So then again I'm calling it for my function for x and null, because I have to leave the last characters. So if I'm leaving the last character here, x left, here does not left anything. So I'm calling it for x and null, because x and null will we can say that in let's say there is only one string and the second string is the null string. So we can say that the longest common subsequence, the length of the longest common subsequence would be 0. So I'm returning 0 from it. Again, y and y matched here, was matched here. So it is going to add 1 to that 0. It is going to return. So it is going to return 1 to it, and it is going to add 1 again, because z and z was matched here. So it is going to add 1 and 1 2, and it is going to return it here. So it will be 2. It will again solve. It will be solving its right part. So whatever the value it will get from the right part, the same algorithm will be applied through the right part as well. So it is going to take the maximum one, because z and x does not match here. That was not matched here. So it is going to take the maximum one. Okay. So the basic what we have understood from here, if the last character of the both string matches, call the function for leave that both character and call the function for both left strings or substrings, because if you are removing something from that, it will be a substring of that main string. And if it does not match, call the from first call that function for that complete s1 and leave the last character of s2, and call the function for complete s2 and leave the last character of s1 into that string, and take the maximum from both and return it to the my calling function. Okay, is it clear now, Vidura? Can we move to the coding part now, or anybody else is having any problem in this? that longest common subsequence that recurs, how we are thinking in the form of recursion. Okay, so let me code it. If we have understood the let's say if we have understood the recursive problem, well, it will not take much time, because we all know that a recursive code does not take much time, or it is a shorter code. Okay, so we'll be quickly writing the code of recursion of longest common subsequence. Let's say what let's try to code it. Let's say I'll be taking this string s1 and s2 from the user. So I'll be typing string s1 s2 c in s1. Let's say I'm taking the input from the user. Okay, so what I'm going to do, I'm going to create a lcs function, longest common subsequence. I'm passing my s1 to it and s2 to it, as well as I'm passing my s1 size of my s1, as well as the size of my s2. Okay, whatever the thing it is going to return, I'm going to just print it. Okay, or you can write just here that longest common subs length of the longest common subsequence, length of longest common subsequence. My spelling is right. So okay, let's create this function. What is it going to return? It is going to return a length, so its return type would be int. Okay, okay. Vidura is saying that okay, I have written a semicolon. It should be comma here. Okay, I hope nerd is fine. So let's say int lcs. It is taking a string, both two strings. So string s1 again, string s2, as well as let's say the size of s1 is, let's say, a, and the size of s2 is b. What if, well, let's first try to write the base case. If a is equal to b, or b is equal to b, or both is equal to b. If a or b is equal to b, it means if any one of the string is null, because if a is equal to 0, it means that uh, one of the string is null, or it can be both. So if this case arise, return 0, because we all know that if any of the string is null, it should be returning 0 only. Okay, and what I'm saying, if let's say if s1 of a minus 1, because a is the size of that string, the last character would be a minus 1, the index of the last character would be a minus 1. If s1 of a minus 1 is equal to s2 of b minus 1, because these two will be the last character of the both string. If both are equal, then what I'm saying, return 1 plus and call the function again, because I know if both string matches, I'll be calling my function again, and I'll be reducing the size of my string. I'll be passing my s1 and s2, but I'm reducing the size of this by 1. Okay, else if it is not the case, I'm saying in that case return the maximum from first leave that, let's say for s from s1 s2 and a comma, I'm passing complete my a string, and I'm reducing the size of my second string, as well as take the maximum from this or this s1 comma s2. So the meeting is going to end soon. You have to click on that link again for joining. Okay, so I'm passing s1 s2 again. I'll be reducing the size of my a, and b I'll pass as it is, and I'll take the maximum from both. Okay, so this is the code for longest common subsequence. Let's give some input. Let's say what was the input of that, what was the case that was we were discussing. It was, I think, x y z and y z, or some, it was x y z x. Let's try to trying to run it. What I'm getting, I'm getting the length of the longest common subsequence is 2. It means I'm getting the correct output. Okay. Let's see if I'm writing x, y, z, y, z again. And here I'm also writing y, z. Now it should be, I think x, y, z is the common uh, longest common subsequence. So I think the output should be 3 or more. Oh, it is 4. The let's see what is the common longest common subsequence. It is x. Okay, it is yz and yz. Okay, y in this first string it is yz, and in the second string yz and yz. So the long length of the longest common subsequence is 4. Okay, is it clear with everyone? Or do anybody is having any problem with this code, with the help with this recursive code? Okay, Shrey saying it is clear. So as we have already talked that why we need a dynamic programming solution for this, because we have seen in the form of that recursive tree that we are calculating the values more than one time. Okay. So what if I say that before calling this function, as I have talked, as I have discussed in the case of Fibonacci as well. So let's see in this case, what if I say that before calling this LCS function, if you have, let's say, first, if you have calculated this 1 plus LCS, you have called this LCS function for S1, S2, and A minus 1 and B minus 1, and just store this value somewhere. If I need this value somewhere any other time, what you need to do, you just first check whether we have already calculated this value or not. Okay, is it fine? What I'm trying to see? Okay, so what I'm going to do, this problem is on the lead code as well, so I'm going to use I'm going to solve it there only. Let's see whether we are able to solve that problem or not. Okay, because here we have to generate the test cases, and on the lead code the test cases would be automatically there. So what I'll be writing, LCS lead code. Okay, the lead code is already there because I used to solve this question. So LCS lead code, this is the problem. Let's see whether we are able to let's see whether we are able to solve it on the lead code or not. Okay, so if we see let's try to see how the lead code is asking the question. Okay, lead code is just providing us the two string, text1 and text2, and it is asking the size of the maximum that length of that longest common subsequence. Okay, so uh, let's call our function here as well. So I'll be copying my solution because I think, okay, let's write it. I'll be copying our function. Okay, so I'm saying return LCS of text1, okay, text2, okay, text1 dot size, text2 dot size. I hope text1 comma text2, text1 dot size, text2 dot size. Okay, let's copy our function in LCS. Let's paste it here because in this case also it is asking us about the length of that. Okay, let's try to run this code. Let's see whether our recursive problem is able to solve this code. Is able to. Okay, it is saying that basic test cases that it is being passed. Let's try to submit it. Okay, I've never solved this problem. Okay, this is my first time also on the lead code. Okay, so it is saying, it is giving us a time limit exceed. Let's see the details. Okay, out of 43 test cases, it is passing the 16 only, and it is saying that time limit exceed. Okay, I'll be zooming a little bit. Okay, is it fine now? Ashish? or do I need to zoom in? Okay. So as we are seeing our submission detail, it is saying that out of 43 test cases, only 16 has been passed, and this was the last input on which we are getting a time limit exceed. It means that yes, we are getting a, so we need to improve our solution and we need to write a better code. And what how we can improve that our code with the help of dynamic programming, of course, because we have already seen that we are calculating the same thing again and again. So if I want to do it with the help of dynamic programming, what I should be seeing that because if I'm calling this function s1 comma s2 for a minus 1 and b minus 1, I can see that if I know, because what the changes we are doing if I'm calling the function again and again, I'm just changing the value of a and b, and I'm passing the s1 and s2 as it is. Here also I'm passing a and b minus 1, a minus 1, b, a minus 1, b minus 1. It means that we are changing only a and b, and we are not changing anything. If I'm calling the function again and again. So what if I create a 2D array? If I say that, because there is only two values that are being changed each and every time if I'm calling my function. If I'm saying that, if let's say here a is 5 and b is 6, if 5 minus 1, that is 4, and 6 minus 1, that is 5, if I'm storing the value of 4 comma 5, if a is equal to 4 and b is equal to 5, if any other time if I need to calculate that, I'll be seeing that whether it is there or not. So for doing that, let's come to our ID again. I'll be writing it here. Let's say that xyz, and okay. So what I'm going to do, because we know that there is only two values that is varying. So for in the case of Fibonacci series, we have seen that only n was there that was varying. So what we can say that here we need a 2D array, because 2D int array, because we are storing the value of int, and we know that there are two values that are constantly changing, because a and b. If there would be only one value, let's say it would have been one only. Let's say it would have been a. In that case, I would need it only a 1D array, because if I want to store it for a minus 1 and b minus 1, so it will be a different value, and a minus 1 and b, for a minus 1 and b, it will be a different value. So what I'm trying to say, that create an int array, let's call it dp, because we usually write that array with the name of dp. It means dynamic programming. Let's give it size, because we'll be storing the value of int a, because in this case we are looking for the solution of int a and b. At the case of a and b, and a is the size of our strings and b is the size of string 2. So if I need to access that index, I should be having the maximum that the size of my 2D array, it should be more than a, because if I want to access the a, it should be a plus 1 na? Because it will start from 0 and it will go up to a minus 1, where a is the size. Let's say int a is equal to, I'll be declaring it here as well, s1 dot size, int b is equal to s2 dot size. Okay, int a is equal to s1 dot size, int b is equal to s2 dot size. So I'll be creating my int p of a plus 1 comma b plus 1, because I have to access the index a as well as the index b. Okay, so what I'm saying, I'll be filling my dp with minus 1 in the starting, because I know it can have the value 0, so that's why I'm not filling it with the 0. So I'm filling all the value with minus 1 first. So for doing that, I can write beam set I'll be passing my dp through it, that 2D array. I'm saying fill minus 1, and I'm saying that size of dp you can take with the help of size of function. Okay, so what this beam set function will do, beam set function will just fill our array or 2D array with -1. Okay, so here I'm passing my DP as well. Now, okay, for passing my DP, int DP, I should be having the size of both because it will be changing according to our input. If you are taking the input from users, so it will be changing constantly. So what I'm going to write, uh, in that, if you are taking the input from the user, you cannot use that array here. I should be using that vector, but let's say the size is fixed. Let's say 2 to 5, it will be 5 plus 1 6, that is 6 also. Okay, I hope you are getting why I'm writing 6 and 6, but we cannot write it something like this. In that case, we have to use the vector of vectors, the 2D vectors. Okay, because in that we don't need to give the size on that give. Okay, so now I'm saying if I want to calculate the LCS of S1 S2, why DP A plus 1 and B plus 1? Again the question, Vidura, I'm saying because what I'll be doing, let's say if I have calculated in the extreme case, what will be the access value? Let's say in the extreme case, because if I want to calculate it for a comma b, LCS a comma b, in that case I should be knowing the value of a comma b minus 1 and a minus 1 comma b. It means in that case I should be having that I can store, let's say the index should be a, the index should be b, because if I want to access the index a, the maximum value of a could be that size of that string. If I want to access, let's say the size of the string is 4, and if I want to access the index 4, I should be having at least I should be having the size 5, because I can, in that case the index will start from 0 to 4. Okay, I hope you got it. Okay, so what I'm trying to say here, let's say, I hope I'm audible to you. So if I'm saying before calculating LCS for S a minus 1 b minus 1, let's say if dp of a minus 1 as well as b minus 1 is equal to -1. If it is equal to -1, then you calculate it. And return it. Okay. If it is not equal to -1, then you should be returning. You should return, because I'm looking for the. You should return 1 plus LCS. Oh, sorry, DP of a minus 1 and b minus 1. Okay. I hope you got it what I'm writing here. But let's say if it was not there in our array, if I've calculated it before returning it, at least store it into the DP so that I can use it next time. Okay. So what I'm saying, that let's store the value of this function into a, and I'm saying if I'm saying that DP of a minus 1 as well as b minus 1 is equal to a. Okay, I'm saying return a plus 1, because I was returning the value of this plus 1. Okay, so right now what I'm doing, before returning that value, I'm just storing it into my DP again. Okay, so let's say if I'm not returning it here, what I can write here, I can remove this else statement, because if I've changed the value of DP a minus 1 or b minus 1, it will be here. So the changes will be here. So let's remove this else condition. Let's remove this else condition also. So I'm not going to return it here. Now what is happening? If it is -1, so first it is calculating and it is storing into DP of a minus 1 and b minus 1. It is updating the value of that and it is returning. If it is not equal to -1, it is directly returning. If it is not equal to -1, it means the value is there at a minus 1 and b minus 1. Okay, as well as in the case of else part as well. So what the value I'm looking for? I'm looking for a and b minus 1. If dp of a comma b minus 1 equal to minus 1, then you calculate it. Let's say then you calculate it and store it into dp of a and b minus 1. Okay, what you have to do, you have to call this function s1 comma s2 comma a comma b minus 1. Okay, as well as I'm checking if dp of a minus 1 and b is equal to minus 1. In that case also you have to calculate the value. So dp of a minus 1, so it will be a minus 1. So I'm not doing anything, I'm just storing the values, and before calculating that I'm checking whether I have already calculated this value or not. So dp of a minus 1 and b equal to, calling the function lcs, passing my s1 through it, s2 through it, a minus 1 as well as the b. Okay, now for returning, I know that I've already calculated dp of a b minus 1, dp of a minus 1 b. Okay, so what I'll be returning, I'll be returning maximum of a minus 1, sorry, dp of a minus 1 and b comma, sorry, okay, let's first write dp of a. You can write anything, dp of a b minus 1 comma dp of a minus 1 comma of b. Okay, so let's say if dp of a and b minus 1 is not equal to minus 1, it means it is already there, so I will not be calculating it, as well as in the case of a minus 1 and b. So if it is minus 1, it means it is not being calculated. So I'm going to calculate it and I'm going to return the maximum from both. If both has been already calculated, so I'm not going to calculate it, I'm just going to do it. Okay, is it fine? Or we can do one more thing, we can what we can do, because let's say, just try to understand why I'm going to write this. If I'm passing return 1 plus dp a minus 1 b minus 1, then this is the value of dp a b. You can see, because this function is this statement is coming under d s1 s2 and a comma b. It means it is going to return. If it is returning, it means it is returning the value for this. So before returning this, what I can say, I can write dp of a comma b equal to 1 plus 1 plus dp of, because dp of a minus 1 and b minus 1 is already being calculated. Okay, so here I can return this, or I can return directly dp of a comma b, because we have already calculated dp of a comma b. In this case also I can write this as a dp of a comma b, because it will be the, because if I'm returning something, it means this is the solution of dp of a comma b. So directly I can write here return dp of a comma b. Okay, let's see whether we are getting the correct output or not. Okay, we are getting the errors. So it is saying, okay, we have not passed our dp, line number 24. Okay, line number 24. So Vidura, you're asking why I've written line number 24. Okay, the comma, sorry. Okay, I have not passed my dp through any of my code. So if I'm passing LCS, I should be passing my DP here. If I'm calling this LCS function, if I'm calling this LCS function, I should be passing my DP through it. Because we all know that if I'm passing a 2D array, it will be by default a pass by reference. Let's see. Okay, again, size OD. Okay, the spelling of size of is wrong. I hope now it is fine. Again, int DP66. So it is saying initializing argument 5 of int a, int 6, and I'm passing int 6 of 6. Then what is the wrong that I'm doing? Size of TP. Okay. So no, I'm getting this error. Initializing. Okay, it is saying cannot convert int star b plus 1 to int. Okay, a plus 1 and b plus 1. I think there is some issue with a plus 1 and b plus 1. What if I'm writing? Because here the size is 1, 2, 3, 4, 5. It should be 6. So it is 6 and 6 here. Size. Okay, let's write 6, 6 here. Then we'll be seeing whether it is. Okay. Okay, the longest common subsequence is 0. It means somewhere we have done it wrong. Let's see again. Let's see it again. Whether where we are doing it wrong. It is saying that dp of, if I'm passing my dp of 6 6 through here and I'm passing my -1, let's quickly check it this function again. And I'm saying if a of, okay, so okay, let's say let's check our function. I think we have done something wrong in this. So dp of a minus 1 b minus 1 is equal to -1. I'm saying that int a is equal to lcs s1 a minus 1 b minus 1 dp, and I'm storing dp of a minus 1 and a minus 2 to a. Okay, fine. dp of a is equal to 1 of dp a. Okay, here it is, right? I think so. dp else a minus 1 b minus 1. Okay, a comma b minus 1, that is fine. A comma b minus 1, a minus 1 and b comma dp. We have defined it two times in function. We have defined a two times. Okay, pair. Okay, defined two times. Okay, I think so. The a is creating some problem. Let's, okay, let's remove this a, because I think I can write directly here. Okay, anywhere else we have used a. Okay, let's see now we are getting the correct output or not. Okay, we are getting the correct output. Thank you, Shay. I've declared the a two times, so I think it was uh, misplacing some values. Okay, so the length of a longest common subsequence is coming out to be 4. It means what is happening here right now. Before trying to call that function for a different a b, it is first checking whether it is there into my array or not. Okay, so from doing this, if we do it something like this, we can save a lot of time. It means that yes, we can think the solution in the form of dp. Okay, if we can solve the problem with the help of recursion. But what if I want to solve it with the help of pure dp? It does not comes under pure dp. There is concepts of pure dp and non-pure dp. It comes under non-pure dp because first we are solving it with the help of recursion, and I'm passing my dp through it. I'm passing my to the array through this function. But if I'm calling my function again and again, it is creating a call stack, because we all know that it will use a stack. If you're calling your recursive function, it will use stacks. Okay, so we are using dp as well as the stack. So we are using arrays as well as the stack. So if I can know, if I can know the solution of that, if I can directly fill my array with the help of iteration, we should not will not be needed that call stack. Okay, let's try to see how our array is being filled. Okay, okay, just 1 minute. So if I'm let's see, okay, just 1 minute. Please do not write anything on the board. Okay, I have removed the permission. So uh, let's see, because we know that our array is going to be filled in some manner. If I can know that in what manner my array is being filled into this problem, I can directly fill that problem without all these recursion. I can directly do that. Okay, so for doing that, what if I'm writing? Let's create a function void print here. Let's create a print function. If I'm passing my dp through it, 6 by 6, it is just going to print it. Or int I is equal to 0, I plus n, I plus plus, sorry, it is 6. So let's quickly see how our array is being filled. Then we'll be discussing about the pure DP. J is less than 6, J plus plus, because in this case we know the size. Also, if you write this solution in the lead code, there is a maximum chance that you'll get a time limit exceed in this case also, because most of in that case we are getting only four or five test cases passed. I think it was 4 5 or 15 16 something. So now might be chance you'll get 40, I think 43 test cases was there. So yeah, I think this code can pass either 40 42, it can pass 43 also. But we can write efficient solution than this. Okay, so we are going to write that, and we'll be directly writing that code. Although if you want, you can write this code in the lead code also. You can check whether how many test cases are being passed with the help of this code. Okay, and what the changes you need to do, you need to, in the place of 2D array, you need to pass a dp, you need to pass a vector of vector, and you need to fill that vector. Either you can fill that with the help of with manually, or with the help of that matrix function is there, I think so. So well, I'll not discuss much about that. If you want, you can do that. And if you're stuck somewhere, if you need any help, you can directly contact me, or you can put your query in the group. Okay, so dp of I j. So I'll be changing my line version. Okay, after, let's say I'll be calling this function again and again, so I'm passing some underscore through it. I just there is no need of this function. I'm just trying to check. Let's say here we have calculated our dp of a comma b. It means if I have calculated my dp of a comma b, I would have changed something. So I'll be passing my dp. I'm going to print how my dp is looking here. And here also, if I come to this case, I'll be checking how my dp is looking here. Let's try to look at our dp. Okay, it is saying that I should be writing a semicolon here, of course. So do not stuck in the solution. Do not worry about the solution. I'm just trying to show you the procedure how you can approach a problem, a dynamic programming problem, if you see it somewhere. Okay, I should be changing my line. Okay, it is saying longish. Okay, I got it, because it is changing here. Should not be writing it. Let's remove it. Let's call this function here, because it is first printing the data, and again in the last it is going to print the value. So okay, let's look at our dp, how it is going to fill. As we can see that first it is left at this one and this one, and it is first making it 0. It means what I'm writing here, because we have taken a big example, we cannot draw the complete stack of this. So let's say it is x, y, z, x, y, z, and y, z. Okay, here it is, let's say it is y, z, yz, x, y, and z. Okay, so the DP is filling something like this because let's say the second string would be the first string would be the, let's say the first string would be the row in the row. I've made it in the opposite way. Let's say this is the first string and this is the second string. So what it is doing, it is filling because although we can see that we have passed our what we have did, we have passed our function from the last and we are calculating it from the last, but it is what it is doing, it is because it will divide it into the sub problems, and sub problems it will come to this here first, then it is going to calculate it as we can see that it is starting from here and it is moving towards the right. Okay, so we can see that how the DP is filling, that it is first going to calculate it because let's say how I'm calling my function. I'm saying that if these two matches, let's say if these two matches, I'm saying I'm starting from the beginning right now. If these two matches, I'm saying that take the maximum of a minus 1 and b minus 1. Let's say this is a minus 1 and b minus 1. The value will be here. Okay, the value will be here. I'll be taking this value and adding 1 to it. If it does not match, I'm going to look at my up and I'm going to look at my left. Which one is the maximum? I'm going to update me as it is. Okay, okay, let's try to create our DP first, then we'll be doing it. Okay, let me erase this. Okay, sorry, let me erase this. Let's remove this print function as okay, sorry, do not do anything. Let's take the previous example again because that was a short example. Okay, it was x, y, z. I'm going to discuss the pure DP now. Y, z, and x. This is the first one and this is the second one. So what I'm saying, the first one would go into the row part. Let's say x, y, z, and y, z, and x. Let's say here I'm leaving one column before, one column before. Okay, just 1 minute. Okay, sorry. Should be. Let's say x is here, y is here, and z is here. Okay. So what I'm going to check. Okay, I would have leave one before as well. So 1 second, just because I need an extra line before that. I'll tell you why I need an extra line. Now I can write this x, y, and z. Okay, let's say let's discuss it from the beginning. Why I have created this. I'll be discussing it as well. Let's say you have given two string with the two string x, y, z and y, z, x, and let's say first start in the starting I'm filling it with the 0. I'm filling it with 0. Okay, why I'm filling it with 0? First let's move to one or two step forward, then we'll be seeing why it is 0. So I'm saying if x and y matches, what we are doing, if an x and y matches, I'm just going to check a minus 1 and b minus 1. Let's say in that case a minus 1 and b minus 1 will be this, because this is 0, this is 1, 2, and 3, 0, 1, 2 and 3. In this case, A is 1 and 1, so A minus 1 and B minus 1, 0, 0. This will be the case. So X and Y does not match, so I'm going to check for A minus 1 B and B minus 1 A. So 0 and 0, maximum will be 0. Again, Z and X matches, no, it will be maximum from these two, it will be 0. And again, X and X matches, yes, it is. Then in that case, what I was doing, A minus 1 and B minus 1, that is this, and I'm adding 1 to it. So 0 plus 1, it is 1. Okay. Now Y and Y matches, yes. So I'm going to add 0 to 1 because I'm going to add this value to 1. Okay. So Y and Z matches, no, Y and Z does not matches. So I'm going to take the maximum from these two. So it is 1. So because 0 and 1 from the maximum, it will be 1. So Y and X matches, no, Y and X does not matches. So I'm going to take the maximum. It is both are equal, so it will be 1. So Z and Y matches. Yes, Z and Y does not match. So I'm going to take the maximum from 0 and 1. It will be 1. So Z and Z matches. Yes, Z and Z matches. So I'm going to take this value and I'm going to add 1 to it because if both value matches, so I'm going to check for A minus 1 and B minus 1. In this case, if Z and X matches, I'm going to take the maximum from this because Z and X does not match here. So 2 and 1, the maximum would be 2. So this would be our final answer in the case of pure DP. Okay. So because why I have written it with 0, let's say if X is there only, if X is there and in the second case, in the second array is null, so X and null, it will be 0, Y and null, it will be 0, Z and null, it will be 0. In that case also, let's say the second array is there and first array is null, so Y and 0 will be 0, Z and 0 will be 0, X and null will be 0 because it will be this. With the because of that nulls, I've created this, and in that case also I'm using these values to fill my DP. Okay, I hope the pure DP is clear now, or do anybody is having any problem? So if it is clear, I can directly write the code here. Okay, so what I'm going to do, so this is the case. So I'm going to write the code here of pure DP. Okay, I'm going to erase all these. I'm going to write a code that should be accepted by this lead code platform. Okay, let's quickly write the code because we have discussed about that. We have already discussed about that solution. Okay, let's remove this function. Okay, so what I'm going to do, I'm going to create an int dp of, let's create the size int a is equal to text1 dot size. Okay, is there, let's, okay, I hope now it is visible to everyone. So text size 1, let's say I'm adding 1 here, so I'll be creating the size of the dp of size a and b. So I'm adding 1 directly a and b, or I can do in that way also as we have already done. Okay, so text2 dot size plus 1, so I'm going to create a dp of a size and b, and I'm going to fill, let's say, well, it does not matter because in that case also we have seen that first we are filling the first row and the first column with the 0, or we can do that, we can completely fill our array with the zeros. We'll be calculating from a is equal to 1 and b is equal to 1. So we'll be updating the values from a1 b1, a is equal to 1 to n, and b is equal to 1 to zeros, my dp with the zeros. So I'm calling my meme set function and I'm saying that fill it with the 0, and I'm saying size of, take the size of that dp with the help of size of function. Okay, now because we have already filled it with the zeros, we have already discussed that our It's going to start from 1 and it is going to up to a I plus plus, and our j will start from 1 of course, because the first row will be by default 0. So we have already filled our complete array with the 0. So we do not need to change that. So I'll be starting my j from int j is equal to 1, from int j is equal to up to b, j is less than b, j plus plus. Okay, and now I'm going to check, because I'm starting my I and j from 1, and I have to check it. I have to compare my string, because strings index will start from 0. So I'll be checking if text 1 of I minus 1, because if I starting from 0, I starting from 1, so I minus 1 would be 0. Okay, so j minus 1 as well. If it is equals to, if I minus 1 and j minus 1, sorry, if it is text 1 of I minus 1, it is equal to text 2 of j minus 1. If both are equal, in that case what we are doing, we are just updating our dp of ij is equal to dp of ij equal to 1 plus dp of I minus 1 and dp of j dp of I minus 1 and j minus 1. Okay, if they both are not equal, so in that case what I was doing, I was just calculating dp of ij is equals to the maximum from dp of I comma j minus 1. Let's say once I'm decreasing my j, and now I'm going to decrease my I, dp of I minus 1 and j. Okay, yes, we have to do this much only. And because if it is going to the last index will be a minus 1 and b minus 1, in that our value will be stored. So I'm going to return dp of a minus 1 as well as b minus 1. Okay, this will be our last index, because the size of our array is a comma b, a and b. Let's try to check. Let's see whether we are getting the correct output or not. Okay, so the normal test case is being passed. Let's try to submit it. Let's see whether we are getting the correct output or not. Okay, so we have got the correct right output, and it is saying that yes, that you have successfully solved this problem. Now we can see in the details that 43 out of 43 test cases is being passed. Okay, so as we can see that the size of this code is very less. Yes, of course it is less, but for doing it, for understanding it, the structure of the code, first we have started with the help with the recursion, and we have visualized that how my dp is going to be created. Okay, although we have solved this problem with the help of dp, and we have memorized with the help of recursion, and we have memorized that in the recursion also, but this solution comes under the pure dp. I would suggest you, if you are new to that dynamic programming, I'll suggest you that do not come directly to dp, directly to pure dp. First try to think in the form of recursion. First try to think the solution in the form of recursion, and try to memorize that, and try to see that how your dynamic programming array, or if you're using array, if you're using linked list, how it is going to be filled. So if you can understand how it is going to be filled, after that you can do it with the help of pure dp. It means if you have understood that how it is going to be filled, it means now you can do that with the help of pure dp. Okay, I hope now it is clear, or do anybody is having any problem in this? Is it clear, everyone? Okay, with raising no problem. Okay, so I'm going to end today's session. So in the upcoming session, hope so we'll be discussing about that divide and conquer. Why I've not given a lot of time to dynamic programming, because I think that dynamic programming needs the practice only. If you know the way of doing dynamic programming, you don't need someone to teach you dynamic programming. I think you just keep on solving the questions, in this form only. First, think the solution in the form of recursion, and then after that, in the form of memorization, then you can go to pure DB. So this will be the a way of doing dynamic programming. So we'll be sharing some more questions with you of dynamic programming. Hope you will be doing that. If you face